Let's see. Should work. Yeah. So I hope this sound is okay. Today I wanted to have a look at modeling the battery cover for the PowerBook 100 series. So people did model the battery case either as a placeholder or to put real cells inside. And I did find some models for the battery door. However, it was either an STL file or of a 3D model export, or a 3D scan, like this one from Ron's computer videos, which is great. It's a start. However, I feel like maybe we could do something a little different, and I just thought also maybe we could also add features like, well, maybe if we don't need the battery, we could fit something else behind it, maybe later. So I downloaded these models, this one and this one from Thingiverse, and I'm gonna start OpenSCAD. So I'm going into a proper directory. I do have the models here. Where's this one and that one? So let's pb battery cover.scad. That's the native file format for OpenSCAD. Yes, great. And first I can actually import maybe this one. I think I need, yeah. Quit. Do I get anything at all? Or will OpenSCAD just hang on me? That doesn't fit into cache. That's a nice start. That's weird. Maybe I can import the other one, at least. Oh, okay, great. So I suppose Mesh Lab. If I open it in Mesh Lab, maybe it's a bit too complex. 3D scans are basically lots of points from the 3D scanners and faces derived from them, but yeah, it's hanging on 94% loading, which is not exactly yeah, okay, it's there. Maybe I just need to wait in OpenSCAD a bit. Hi Glucky. Yeah, didn't seem to. No, didn't fit into cache. So yeah, it's probably just too complex to get it into OpenSCAD. Never mind. We do have calipers and other tools, and we have another model, and we can always use Mesh Lab to compare. It's just, yeah, quite slow. Yeah, so OpenSCAD, lol. Yeah. And yeah, let's document this. Guess I'm a bit too tired for typing properly, maybe. So this model is flat. Okay, it's laying on the face here. Yeah, runs more or less in a different position, but well, that's okay. Yeah, this one misses quite a lot of features inside, like the sliding tabs used to slide on the battery, because of course it's probably yeah, battery cover. It's just for people who just want to cover the hole without having the battery inside. But we can add that. So here, yeah, that might be an interesting challenge. That's probably going to take several nights, but well, why not? Because yeah, there are different radius and fillets and stuff like that. And here I do have a nice tool which I 3D printed here at Fabrico. which which does have a fab lab. So it's 3D printed, and I used a black marker to get the numbers more visible. And it's basically a tool to measure the radius from various pieces, so you can see if it fits or if it's too narrow. This can prove quite useful later on, I think. And yeah, let's have a try. So yeah, I think we can start by making a rough model of the basic shape, and then I probably won't finish today anyway, but I wanted to have a try at least for Macintosh. Also, this model you see here doesn't have the raised parts for the grip. Instead they cut into the shape, because it's easier to 3D print if you lay this face on the bed. But in case someone wants to make a resin print, maybe possibly they want to get the more accurate part. So this we can later add an option. I usually have add an option to optimize FDM prints, which converts the raised parts to cutouts and stuff like that, and make supports other parts like larger than the original, because they are sturdier this way. But we can start by modeling the original part. Yeah, I'm going to add some lines, because the tool I use here to show the key presses is getting in the way. Oh, let's switch back to the screen. Yeah. So yeah, let's see. I believe we can probably do something like a hull, maybe between some cylinders and other stuff. And then we can probably do an offset to remove the internals. So which what's the diameter here? This is 5 millimeter. The radius, yeah, this one is closer to 6, 7. Yeah, 7. I'm not entirely sure it's really a cylinder. It seems to be, maybe it's a bit larger when it's getting to this end. Anyway, yeah. We can probably start by doing a 2D module, and then use it to construct the 3D shape. So I put like cylinder. Well, if I want to do a 2D shape, it's going to be a circle, or so I have a 5 and 7, I said, I think. So if we want to see anything, we need to instantiate the module here. Of course, I forgot to switch back to the screen. So yeah, module basically declares a shape or something that we'll be using later. Here I just put two 2D objects, a circle. And here I'm instantiating, and you can maybe you can see here it already added a cylinder, because when you instantiate a 2D module and you don't use it to construct a 3D shape, it automatically makes it into a 3D shape. Let's move it out for now. Translate in Y 0, 10. Maybe that's a bit too much. Not enough. Yeah. So now I want to translate to put both circles into position, and yeah, I suppose the model is centered, so I have to take some measurements, and yes, well, this caliber is hard to, yeah, okay. So the object is like 28 millimeter in width. We'll have actually let's make a bounding box. I'll color it with a little transparent color. Let's make maybe green and 0.3 maybe. Cube. All well, no, a cube can have a different dimension in X, Y, Z in OpenSCAD. It's a bit weird, but basically you can a cube is a cube that can be stretched in either dimensions. That's weird, but yeah. So in Y, that's 28. What's the total length here? 116. Actually, the 28 maybe. Is it really 28? Yeah. Yeah. What's the height of the thing? Yeah, 7.34, 35. Okay. By default, objects like cubes have one of the corner that's at the origin. So if you want to have it center, we have to declare it equals true. But then the z-axis is also centered, so we have to actually translate it, which is, yeah, a bit weird. There is something called POSL2, which is a library that makes it much simpler, I suppose, to write models in OpenSCAD, but I haven't got around to start using it yet. So if it's 7.735, I translate it by half of that. There's no point in actually putting the result of the division here, because OpenSCAD can obviously make the division by itself. And it's not exactly centered either, because yeah, whoever designed the other model did not really center it. But well, that's okay, we can accommodate that later on. Then, or maybe I can actually, there's like 1, 2, 2.5. Maybe I can actually translate the imported model. So in the x-axis, yeah. Almost perfect, yeah. Yeah, it's probably a bit longer, but yeah, that's okay. So now we have our bounding box in green. We have the original model here, and then yeah, let's translate this. So the smaller circle in the this corner, so it's positive y. So basically, so that will no, it's not 28. What did I do? That's weird. Oh, yeah. X is okay, but oh yeah, I need to remove this one. I can comment part of it and cancel the translation. So here I have the circle that's, and I'm not entirely sure the center is correctly positioned, but yeah. Minus, well, I can probably use variables, so I set this radius here, so I can use it here and here as well, minus R1, minus R1, and yeah, it's invisible of course, but it's there. So if I ever have a better measurement of this radius, I can adjust it directly. And I break the line here and indent this so it's more legible. Let's make something like R2. And I can, not sure exactly what's the default, yeah, radius. So I can just pass R2 directly here. and of course it's minus, either parentheses or just plus. Yeah, it's not too bad. Green, yeah, super green. Looking at the chat, I can probably instead of translating it on the side, I put it above. Yeah, it's probably easier this way. Then thinking I'd probably make a cube there as well, a square, as we're thinking 2D shaped at that point. And yeah. So here we pass the x and y sizes. I should probably define this somewhere. So it's 116 and 28. So that's the 2D bounding box for this shape. And I can actually reference the first item of this array as bbox.x. In OpenSCAD you can actually use either this notation, use the 0 index, or if it's the first 3 you can use .x, and then we can have anything like 1. I don't really care for now. I want to center it, and yeah, actually I meant rather y1 on this side, and yeah. And I want to move this to in x, so minus, plus I'm just here offsetting so the side of the box actually aligns with the side of the object here, because I know it's 1 millimeter thick. I want 0 here on y, and there's an extra parenthesis. And of course I got the wrong position. It's not here. I want to cut rather here, so I need to measure how long this is. Let's switch back to here. Here I want to measure the basically the extra extra size of this bit here. Some people used, and I also did use this part of the caliper, but then did watch a video showing that there's another tool behind it that's used for that, and you can actually use this to measure this kind of things, which is more precise because it doesn't move this way. So here, if I bump into, 4.6, so let's remove let's move it here. It's, we can always change it later, but it looks good. I don't have any radius here, so I can just use this, and then I have to handle the cut here, but that's okay. I won't need it for the cut on the walls here, so we can construct a simpler 3D shape and then do the side cut afterwards. Okay, so I have the 4 corners here, and there's something nice in OpenSCAD, which is hull. Basically, let's in on this. And there you go. So you have basically the shape that well, it's like if you use a rope around all the objects and you tighten it, and you have the smallest shape that encompasses all the objects you do the hull for. That's quite handy. You can also use it for 3D objects, like you can use it on spheres and other things. So yeah, that's a start. Yeah, and I'm thinking of the 3D stuff. Inside, yeah. Let's make a simple version first, and we'll handle the radius later on. So for now we do have a simple 2D shape, and we want to extrude this, so we can do like yeah, we can do something like linear extrude. So we need a number that's the vertical, the height of the extrusion, and we can also do scaling. So if you want to shrink it while it's extruding, or enlarge it, that's possible as well. Let's start with this. Now I can probably start making a module for the 3D, the main body, actually. So this is the bounding blocks, and let's move this and let's declare a module like PB1XX battery cover, and yeah, we can later merge the first module inside. You can actually nest modules, but for now I'll just leave it like this. So modules are a bit like a function, but they, instead of returning a value, they return a 3D an object, either a 2D or 3D object. So yeah, this doesn't change anything on the output. And we might want to remove some matter now. So you can use the difference operator. Basically, we can we can start with a cube, maybe. If we remove a cube, well, you see there's a cubic hole inside. You might see some stripes here. That's because the bottom face of the cube actually touches the bottom face of the other object, and well, with constructive geometry, it's some kind of things you don't want to have. So if we really wanted to dig a hole inside the shape, we'd have to do something like translate 0 minus 0.1 or something. So at least the cube is it starts below the bottom of the other shape. Well, this way we can actually see through it. But that's not what we want. So we can actually reuse basic shape here, and well, we can keep the extrusion, but except we want to have a smaller shape to remove. We could try to scale it. There is some scale operators in OpenSCAD. However, it won't really work very well for objects which have dimensions that are not similar. Like this one is longer than it's wider. And here you see also again these stripes, because both bottom and top faces of both objects actually touch each other. So if we want to have something that looks correct, at least we have to translate it like 1 maybe. But that's, yeah, not exactly what we want. We can actually scale in differently in 2 directions, but in like 9 maybe. But yeah, it's each time you will change the parent object, we will have to correct the scaling. And also for other details, this shape is quite simple, but with other details it won't really help. Instead, there's something called offset, which takes the parent shape and actually offsets all the faces by a fixed amount. So I don't remember exactly which version I need, so I have to do some testing. Yeah, I think it's probably -1. yeah. So here we're telling I need to indent this better. Yeah. So why do I have this? Yeah, translate. So we both have two instances of this basic shape here. The first one is extruded, and the other one, first we apply a negative offset, so we make it smaller, and then we extrude it. And of course we don't want to have a hole at the bottom, so we translate it upward. I will probably want to measure how thick this is. So let's see. There. 2.55. Yeah, something like that. Okay, so we do have something that starts to resemble something we might use. However, at the bottom we do have yeah, it's quite angular. We want to add an offset here. There are actually several ways to do that. There's one that should work. Yeah, it's another quite interesting operator, which is called Minkowski. This one takes two objects and basically it takes the second object and moves it around all the other one, the first one, and usually you want to use it like with a sphere. So I need to measure the radius of this. It's something like 2, I think. Yeah, it's definitely not 1. 2. It's not 3, it's smaller. So yeah, 2 might do. We could also have used something like linear extrude towards the bottom, either by flipping the resulting object or something like that. This with a scale, but it wouldn't be round here. It would be like more a straight line. So it's not really what we want. Sphere 2, and of course, yeah, it does change a bit the shape of the object, and it also makes it bigger in all directions. So we have to correct this. We have to compensate. First, I want to add some. I never remember. I never remember which one I want to use, so I go searching for OpenSCAD. If Firefox wants to open OpenSCAD, that's interesting. Cheat sheet, yeah. I just want to load it here. I just noticed screen key actually uses the French names for the keys, but well. Yeah, these variables here, these are special variables. Where are they? Yeah. Minimum angle, minimum size. These variables affect rounded objects like cylinders, circles, because OpenSCAD, when it renders, it always does flat faces. It doesn't really render cylinders. It knows what a cylinder is, but when it renders an object, it just makes something with facets. So we can tweak these variables to select how many facets you want, depending on the side of the object, and yeah. So I can just set the number of fragments to something like 20, and yeah, it's a bit better here. It's not exactly what I want, but for previewing, at least it's okay. So yeah, back to Minkowski. The problem with Minkowski, if when you're starting from an object like the one we modeled, it adds the radius of the sphere in all the dimensions on all faces. So we have to actually offset this as well before to compensate, and we will also have to cut the top here, because the top of the original one is flat. So maybe you can usually you want to extrude a little more and then remove the top, like with by doing a difference with a cube or something like this. So yeah, it seems no, it's not okay. Oh yeah, of course. I'll use this, so there. Yeah, that's better. Ooh. Okay, so I want to extrude like, we can do 10, it's okay, and then we already have a difference here, so I can also do the difference with and this one is badly indented. Translate. I should probably I should probably only have one copy of these values, but for now it's okay. I'll make the 3D version of the bounding box. Yeah, of course it's not happy because I started writing something and didn't pass any parameter to translate. So well, but that's okay. 0 0 bbox.z cube I can probably just use bbox plus, you can actually do additions on vectors. So here I want to just take the bounding box and move it upward and enlarge it a little, so it won't leave infinitely thin walls. So 1, 1, 0, and I don't even know where it's at. Oh yeah, okay, yeah. So of course I didn't tell the cube to center itself, so it went in the corner. You can actually use the hash in the code to tell OpenSCAD to preview the object, so you can actually see it separately. So yeah, I want to center this, and then I also want to translate, so I account for the cube's height itself. Yeah, so it's 7. It's the total height plus half of it, so 1.5, and it should work. Yeah, looks like it. Yeah, except here we did have some rounded corners. It might work, but depending how we cut it, we might have some leftover fat that's getting inward here. So yeah, I want to move this square here. I want to move this a little further on the left, and then I'll cut it properly. So on X, we can subtract. Yeah, I can use 2. That's okay. Okay, not too bad. Yeah, it doesn't feel really right, this corner, because it's larger. It's the same size number of segments, so maybe minimum size. Angles. I can probably use 30 here. It's not a very, yeah, that's okay for now. I wanted to check something. Firefox is slow. Because, yeah, I think that's it. I think it's like an hour or something. Oh, it's in 2 hours, okay. Where did I put the correct window? That was this one. Ah, yeah. So in 2 hours we have Old World Tech Fridays. So you might want to check this. And I'm swapping. Oh god. Right. Anyway, back to OpenSCAD. So we do have the basic shape here, except yeah, there's this cut here. We can probably do it later on, but yeah, that won't fit really well with Minkowski, I think, so we have to cut it later on. Yeah. So now I want to cut this part and this part here. And there's a radius here, and one here, and then here. Yeah, this is not straight here, as it won't be funny, right? So there are several ways to do that. I could probably, yeah, subtract a square, a cube there, a cylinder. Yeah, that might work. So if yeah, so that's the inside. Cut out. So yeah, we can do that. Like put some cubes around. So yeah, but then how is that? That's 3mm. Okay. So and in this direction. 29. Yeah, that can be a bit more. Let's say 30. Say 3mm. I can go for 10 for the height. I don't care. We'll have to translate all this a little downward. I can use braces to translate several items here. Where does it start? Can probably do this like as a guesstimate. Yeah, minus. Well, that's 3mm thick, so If I center it, of course. That would be pbox dot y minus 3, half of that, something like this. Okay, wrong direction. Oh yeah, of course. That's also half of that. It's getting late already, and yeah, I have the total 16. If I measure this, this goes to this way, 82. So 82. Of course, it's never in the right direction because, well, yeah, and it's 30. No. What's wrong with that? Actually, it's yeah, makes sense. So 82 is from here to here. So from here it's 82, and in that direction it's half the bounding box. So yeah, something like this. Yeah. Oh, forgot a. Why is that? Oh yeah, center. So it's only 5. Yeah, that's okay. And then I have, it's a little bit thicker. Well, I can always fix that later. However, here, yeah. Excuse me. So here I want something more round, and then the other direction. How do we do this? Very good. Yeah. Which radius is that? That's 1 or something. Yeah. Is it bigger than 1? Yeah, I probably want to do this separately. So let's say 5, 30. But I need to move this to can probably where is it? Where is it gone? Yeah, of course. That's 0. Yeah, something like that. There's also this one here. I can just take the same one and just rotate it. 0, 0 on the z-axis. It's probably a few degrees. -10, of course. Too much. Yeah. Too much, I think. Actually, yeah. That's the bottom view. Maybe like 9 degrees or something. 8. Yeah. Let's just translate that. Yeah, not too bad. Okay. Let's go. Yeah, it extends up to there. So yeah, not too bad. I believe the bottom is too thick. Yeah, right. I didn't take the effect of the Minkowski on the bottom, so I need to so that's the top. Okay. inside cutout translate. Yeah, that's the problem with Minkowski. It also adds the radius at the bottom, so you have to translate it back to the top, which is its bottom R. Yeah, much better. So I still want to fix this. There I want to yeah, which cube is this? Is this one? I can probably do something like this. So I'll just take the same cube and yeah, I translate the whole thing a little more on the left here, and then this one I translate it back one to the right, but then I'll shift it toward the outside by 1, because it's the radius we have here, 0. No, wrong direction, of course. -1. Yeah. So here I just need to remove a cylinder as well, and that should be it. Here we really want to put the radius twice, or just because else the second one will be 0 and it will make a cone, I think. So if I do this, actually no, I thought, yeah, the second radius defaults to 1 or something, so it's okay for our case, but yeah. You can also just name the parameters, so R is just the fixed radius. If you use R1 and R2, you can actually make a cone, like in the other direction, but yeah. But then I need to translate this back to, yeah, something like this, and yeah, not entirely sure. Yeah, it's not perfect here. Yeah, here. Yeah, I guess that's okay. There's like a really tiny segment here, but when 3D printing it won't really oops. Yeah, that's okay. Really, there's tiny face here, but and then here we want to probably yeah, we can probably remove we can do difference inside a difference. That's something we might want to do. It's not the intersection. Yeah, that could work. Or yeah, because basically these cubes, which is which? Yeah, this one. This one. This one's okay. Yeah. Let's sort them. Yeah. By the order in which they are along the face. At least there are some order inside. So yeah, this I don't need it to be. It can be no. Can be 5 here. Which is this one? Yeah, that's the one. 3, but that's okay. Yeah. Okay. I need to have it a little there. I think it's more like 2 millimeters. This radius, a bit smaller. Yeah, it's not 1. It's probably 1.5 because why not? So yeah. There, and then I want to remove. Indentation doesn't really work correctly when you have these modifiers here. Cylinder. equals 20 or equals 1.5. Yeah. And yeah. It's not exactly what I want because it's not removed from the correct position. Yeah. Also, is it yeah, cylinders also can be, well, the radius itself is centered, but not the height, so it starts from the origin upward. So here we want to center it as well. Yeah. And then I want to translate it. Where is it? Oh, almost. Yeah, I guess the why? Ooh. Not too bad, but it's, yeah, not exactly correct either. Yeah, okay. Yeah, looks like it. By the way, you can notice that there are some default colors on the objects in OpenSCAD, and basically depending on the color scheme, there's one color for the things that's constructed like positively, like there's a cube or whatever, and there's another color for stuff like that results from removing matter. So the outside is blue here, and the inside is like more orange. It helps, but sometimes it's weird. Like this part is blue because except we did remove the cylinder, and then we used the resulting volume to remove some more matter. So maybe it just counts the differences in the abstract syntax tree and just uses modulo 2 or something like this. But well, that's okay. So it's not too bad. Yeah, there's yeah, right. This clip here. Also, yeah. How will I handle the this? How to handle this? And yeah, I'm not even sure the. Yeah, it's 1 millimeter. 1 millimeter. Yeah, and how deep is that? Basically here I have 2.6. Yeah, and inside it's more like 1.6, so it's 1 millimeter deep. Oh, also, right, I just noticed the when you view it like this, this part has a little angle. It's not exactly in the same plane as this part here. That's the kind of thing we won't be able to reproduce with FDM 3D printing anyway. But yeah, yeah. Not sure how to handle this. I can probably shave a little the thing. So, a lot of stuff in here. That's the, yeah. If you get lost in the text, which does happen, you can use the marking of the braces. Like if you click near the brace, you see the opposite brace that's highlighted. That's handy. So, yeah, difference. Let's, which one is that? Yeah, of course. Not sure how to name that, but I can just make, yeah, one cube for the vertical part and one for the other one. So I do that later. Cube. X plus 2. Height is, let's just make it 2 because I need to have it, it must be a bit higher anyway, so and then oh no, that's for the height. Width is 1, height is 2 here. Center, yeah, it's usually, well, it depends, but quite often it's easier to just center cubes. Then there, I want another cube of 1. No, actually 2 in X, 1, and height that can be 20. I don't care. Yeah, of course, translate is Mm-hmm. Yeah, that's okay, and then I need to move it there. Mm-hmm. Mm-hmm. Um, 6, 7. Yeah, not too bad. It's quite on the point. 6.9. Well, it's not like yeah. 6.9 is okay. But then inside here we have a whole ideally we would handle this on the basic shape here. So yeah. I could probably do a difference between everything, all the hell here, and the little square. Where is it? So here we're in 2D, so that would be actually not this one. Okay. And then it goes to render something because, well, it didn't like that. Yeah, sometimes when you do, yeah, that's because we use Minkowski, and yeah, sometimes it just does weird stuff. Okay, it's not exactly what I want. Yeah, that's the problem because the same shape is used for the inside and outside, and then for the inside we do an offset, but then for the outside we use Minkowski, so it has the indent, but then it just used the it just passed the whole sphere around all that, and it's ugly, so it's not what I want. So I just undo. And I just leave this one like as it's for the outside, and we just remove remove it later on, but for the inside, before doing the offset, I can do difference difference with, I don't need the braces here. And it's getting quite indented. Did it produce what I want? Yeah, pretty much. And that's about, yeah, it's kind of like it. Yeah. Oh, there's a little radius inside. Seriously? There's a little radius around here. On the inside, if I point it, that's not easy. Basically, from on this wall to the top, there's a little radius here. It's so small, I can probably fake it with the linear extrude. Yeah. Linear extrude. So we have basically the this shape here, and yeah, I can probably reuse that. There's some that would result in some cut duplication, which I can clean later on, but well, I translate this to 7 minus 1 or something. Linear extrude, and I will extrude for like 2 millimeters, and scale equals except since the on the x-axis I want like 1.05 or something, and 1.02 maybe. Yeah, even that's a bit too extreme. That's funky. What's this artifact here? Yeah, so I really want like 1. I think it's not too bad. Yeah. Yeah, I think it's probably enough. No. 0.5 and if I extrude for one, yeah. It's really for the sake of it. Okay, not too bad. Then there's this clip right here. So here, that could be a cylinder, and yeah, basically that could be a cube with another cube removed. Yeah. How large is this? Oh, I forgot I was on the camera. Sorry. So yeah, you missed this part. Yeah, I actually copy pasted the this shape here. So it's again here, except I added a scaling factor and it's much thinner. But if I do like something like this, or rather this one, you see it it extrudes and enlarges further along on the other axis as it extrudes. So yeah, because doing a proper radius here would be quite tedious. I'm not even sure I would know how to do that. Probably BOSL2 would work for that, but that's okay. And then there's this clip here, which is like, it seems to be, well, yeah, okay. So it's 6mm. It's like 8.6 long. So I have to translate something. L is a cube. What did I say? 9. Yeah. 8.86 and by 6. As for the height, it's like 2mm maybe. Yeah, 2, but then the base needs to be a bit larger. Oh, actually, yeah. The one on the model I imported is a bit different than the original part, because here it's just a straight cut, whereas here it's rounded, but well. forgot the square brackets. Minus. So here on this axis we want to have oh, actually yeah, yeah, we wanted to touch it anyway, so but yeah, so I want to have it a little thicker. That's the whole, yeah. I believe the other model has it thicker, probably because, well, to make it sturdier with FDM printing. But well, oh, I forgot something. Center. But then yeah, okay. Something like that. Yeah, that's okay. Yeah. And minus 5, maybe 5 point something. Yeah, looks like it. Yeah, first use this. So it's forgot something. Yeah, difference. So I want to rotate on the y-axis. Probably more like 45 degrees. Yeah. Maybe 40? No, 45. We can probably trick that. Translate. Not too bad. Yeah. And we also want to remove this part here. Maybe a bit too much. Yes, this as well. Yeah, I can probably live with straight face in there. Yeah. Yeah, that might work. And then this one does not need to be rotated. That's something like 2.5. 2.5. Mm-hmm. That's a bit much. So that should arrive here. Mm-hmm. So let's make a copy here. Mm-hmm. Yeah. Okay, that's fine. But then, oh yeah, this one needs to be useful. So it needs to go up. Maybe not as much. Mm-hmm. That's okay. And then mm-hmm. Mm-hmm. 2.5. Yeah. Not too bad. And then I need another one. That's ugly. Okay. This one. Yeah. That's not better. Well, actually, I think that should be okay. Yeah, that's. That's fine. Really, it's not too bad. Yeah. So next is the grip stuff. I don't even see it here. Where did I put the building box? That's weird. Oh yeah, it's here. Yeah. Yeah, there's 16 hands here, but the original model has only 5. And then yeah. This, no. Yeah, okay. It's case sensitive. This will hide this variable from the customizer, and then I will add another category. Yeah, I don't remember. How do I call it? Print options, yeah. So there I add a boolean for later, so we can choose to optimize for FDM printing, like fused deposit material, whatever. Because for this part, I will model the correct version, and then I'll add something like this for 3D printers, FDM 3D printers, because for resin we don't want it. So that's something more in there. So that's the retaining clip. So I'm going to have a slider thing. Basically, it looks to me like cylinders on their side, like 2 millimeters diameter. So when radius height is something like 8. Yeah. So if not optimize FDM, because we don't want it for the FDM optimized version, I'll make a for loop because it's basically the same shape repeated 5 times. I usually do it like dx delta on the x-axis from 0 to I don't remember 4. Yeah, that should do it. That should do it like 0, 1, 2, 3, and 4. Cylinder. So I said, I think 8. Yep. Yeah, that's it. Radius is 1. Translate. Yeah. Plus dx times. What's the delta here? It's like 4. It's not exactly 4, is it? Yeah, 4 times it's 16, so yeah, that's 4. 4. I'll have to offset that again later, but and then I want to center them, and then I also want to rotate them on their side. So on the x-axis, we're in degrees here, 0, and yeah, not too bad. I think they are centered from, a little bit on the right, so -2, something like that. Yeah, they are a bit centered from this on this part, and then it starts at 3.3. I can probably add plus 4, so 9 maybe, something like that. Let's see. 10. Yeah. I can probably hide the part here for now. Yeah, not too bad. Then there's a little triangle. There's an easy way to make a triangle in OpenSCAD, which is to actually make a cylinder. Well, the diameter of this, it's like 4 or something. It's a bit more than 3. Let's say 2. So I need to move it, translate. Plus 16, plus 20 maybe, no. A little more. Not as much. Yeah. But then we actually don't want a cylinder, we want a triangle. And the easy way to make that is to force the which is number of fragments to Fn, Fn equals 3, and voila, you've got a triangle. So it's a cylinder with only 3 faces around it. It feels like cheating, but yeah, it works. Yeah, I'm not sure the exact size or height, but I think it's a little less. Well then. Let's say, yeah. Okay. And then there was a lot of stuff inside. Not even sure this model has. Yeah, it has these, but not the other ones. How many are these? Yeah, okay. So there's these little tabs here. I used to slide the cover on the case, and yeah, basically it's like 1 millimeter or even less. That's gonna be hard to measure. Yeah, let's say 1. 9.6, but then so it's a little inside. It's a bit rounded. Yeah, I think I can probably make a module for that. Yeah, that's for the I'm not even sure if the details were required for molding. Probably. Yeah, I can go for the easy way for now. Yeah. Now let's make one first. Right. I do something like cylinder, let's say 2. Dx equals except the problem is they are not all the same length. The first one that are inserted are a bit longer, so yeah. The default length is 5.6. So yeah. Remove one of the cylinder's diameters. So I translate cylinders in both directions. X times oh, what was that? There's something fishy. Okay. There's something weird. Morning conversion. Oh, right. There's something it doesn't like. But then what's that Um, did I screw up something? Okay, definitely screwed up something. Oh, or yeah, okay. I didn't screw anything up. It's just I somehow managed to change the view for the this, which just adds all the volumes, including those that are subtracted. So it might help sometimes, but usually it's not what you want. No. Let's. Actually, I don't want to rotate this one here. Just. Yeah, let's see. Okay. So I just took 2 cylinders and made a hull of it. So one here, and then I want to rotate this. I can do it probably this way. I just use fake numbers for now. Yeah, but then I also need wanted to avoid doing it twice, but then I suppose, yeah, dx. Yeah, there are some other ways to do this, but I should do a for loop and then another one. So rotate on x. Yeah. Translate. Minus. Oopsie. I need to find the elevation of these. Well, that's like, it's like, yeah, 1 millimeter to the top. Oh, 0.9. Yeah, 1 millimeter to the top. As one, let's see, so 1.5. So ebox.z minus 1.5. That seems more than that. Yeah, no. And then where to position them. So the first one is longer. Oh yeah, there's 4 on this side. So this one is 9.5. So the first one, yeah, is different, but well, that's okay. About 26 apart. 13. And the next one is the same. And here I will change the parameter depending on the dx, the value of dx. If dx less than 20, whatever, I can 15, yeah, I'll say 15. Then I use a larger one, so what did I say? 9 point, yeah, and the default is 416. 8.6. Yeah, that's okay. No, this doesn't look. It doesn't seem correct. Oh yeah, -15. Yeah. So I have the long tab here, the smaller ones. They're not, maybe not exactly in the correct place, but they're about that spacing. And on the other side, I just copy this, and then there's something like -15. Translate. So dx minus plus rotate -90 degrees, and yeah, almost there. Yeah, looks like it. Let's put it more closer to, yeah, something like that. Actually, the other one here seems to end about the same place. So yeah, I probably need to oopsie, to slide that around. Yeah. Mm-hmm. Mm-hmm. So 6 maybe. Yeah, looks like it. Not too bad. And then yeah. Oh, there's some text around, but well. And then there's these clips that hold onto the battery. 8 by, it's like 3 millimeters. 8, and the height is 2.65. 8 by 3. Mm-hmm. Why there are, since there are symmetrical in both directions, well, I can do 2 loops. I can do a single loop with multiple variables, if I remember correctly. -1 1 dy. I usually tend to just use these as a sign and multiply by the actual value, so I don't have to fix the value twice for the offsets. How could I do this? Oh yes, I can do an intersection, because they are like a slanted cube or something. So you can do intersection of intersection of a cube of 8 by 3 by what was the height? 2.6, let's say 3. It needs to be inside the rest of the volume anyway. 3 center equals true. And another cube rotated by something like, I don't know, on the x-axis 30, 20, hard to tell. Let's translate these. Donc, so dx, they're like 28 apart, so times 14, and well, I position them later. Gy is like 15. Let's say 14 is actually 7. Okay. Oh, that's ugly. Oh, yeah. Except I need to rotate dy times 20. Yeah. And it's not exactly what I want. So this one must be higher. Yeah, something like this. But narrower. So this cube. I think it's more like 30. It's it's more something like that, I think. Yeah. How would I measure this? 12.8 and there. It's 1 millimeter difference. So 0.5. Just as a reference, where are these? Oh, oh yeah, translate. I want to translate the whole block. Yeah, okay. 0.5. Okay, so it's, yeah, not that far from I think that's reasonable. So I need to pull this down. Looks like it. Yeah, I have to make some more measurements and move this around, but it's not too bad. So we do have these. I will just make the FDM optimized version here. So instead, if I go to the customizer and I click optimize FD and it just removes this, then I take the code here. Where is it? So great, yeah. I do something similar, but except I will remove it from the main volume. So in this case it's optimize FDM. I could probably do it like this as a reverse. Yeah, that might work. It might actually work better than the model I imported, which had a flat surface inside there. So when you put it with this face on the bed, it might actually work better. Yeah. So here I can go to the customizer and say I want this or this version or this version, and then yeah, export it as SCL. I'll probably add some more reinforcements for part like the clip here or the FDM version and some more details, but I think it's not that bad. Yeah. So thanks everyone, and see you next time. I don't know when for now, but yeah. Bye.